Hey, fifth grade, how's it going? So today we're going to continue working with order of operations. Again, order of operations is one of the most popular math topics that you're going to learn in fifth grade, even in sixth grade. Right now I'm teaching the same topic to sixth grade, but just a little bit more complex. So let's jump right into a couple of problems that you're going to see on page 30. Okay, so inside of your prime math book on page 30, you will see these problems. Let's do a couple of them together, and you'll do a couple of them on your own. All right. So the first problem that we have is a addition problem and multiplication problem. If you remember correctly, you always do what's the multiplication first. Okay, so what we're going to do is just come right back to the steps for doing order of operations. We always start with the parentheses, and then we go to the exponents, and then we do multiplication and division before we do any type of addition or subtraction. So that is something that you need to remember for this problem. 6 times 8 is 48. So let's do that. 6 times 8 is 48. And we're just going to add the next number, which is 84. So 84 plus 48 is going to be our final answer. We can do that right over here. 8 plus 4 is 12, and 8 plus 4 plus 1 is 13. So our final answer is 132. All right, our next problem has subtraction and multiplication. We need to do what's multiplication first, right? So the multiplication is going to be the first part of our problem. So again, just like I did before, 40 times 3. Well, I know 4 times 3 equals 12. So since 4 times 3 equals 12, this is going to be 120 because we're multiplying it by a factor of 10. So then I just take 140 minus 120. 140 minus 120 equals 20. All right, so there's your answer for your second problem. What I'd like you to do is pause the video and try to do letter C and D on your own. Okay, hopefully you paused the video and you checked out those two problems on your own. If we do the division first and then the addition, we would come up with, well, 32 divided by 8 equals 4, and 46 plus 4 equals 50. All right, so that's your final answer for that problem, 50. Here we, again, do the division first before the subtraction. 60 divided by 4 is 15, because 15 times 4 equals 60. And 100 minus 15 equals 85. All right, so there you go. You have your first 4 problems on page 30 complete. We're going to go to the next couple of problems. Letter E says 8 times 6 plus 14. Again, we're going to do multiplication before we do any type of addition or subtraction. So let's do that. Here we go. 8 times 6 is 48. And 48 plus 14. You can maybe do that in your brain if you wanted to. 8 plus 4 is 12. Carry the 1. 4 plus 1 is 6. 62 is your answer. All right. Next problem. Well, we have division. We're going to do that one first. 18 divided by 6. If you look at my multiplication table, 6 times 3 is 18. So that means that we're going to put a 3 right here. And 80 plus 3 equals 83. That's our final answer. All right. Next couple of problems are pretty simple. We're going to do multiplication first. 12 times 10 is the same as 12 times 1 times 10. So 12 times 1 is just 12, times 10 is 120. Now we're going to subtract 5 right here. And when we subtract 5, we get 115. That is our final answer. Okay, let's do that last problem. Last problem says that we need to multiply 6 times 6 first. 6 times 6 is 36. And we take 72 plus 36. 6 plus 2 is 8. And 7 tens plus 3 tens is 10 tens. So 108 is our final answer. All right, now those are pretty simple problems. If you have any doubts whatsoever on the problems that we've done up to this point, please contact Mr. Joseph. We've done lots of different types of activities when it comes to order of operations. We've played this game, abcya.com. We've also looked at other different types of games. Okay, so if you have any problems with these types of things, you can ask Mr. Joseph. We've also looked at a concept called exponents. Okay, when you have an exponent, for example, this problem right here, you would take 2, which is our base number, times our exponent, the number of times that our exponent shows. So for example, 2 to the power of 4 would be 2 times 2 times 2 times 2, which equals 16. If we have 8 to the third power, in other words, 8 is our base number, and 3 is our exponent, we would take 8 times itself 3 times. So in other words, 8 times 8 times 8 equals, well, 8 times 8 is 64, right? So 8 times 8 is 64, and then we just take 64 times 8 one more time. 64 times 8, 8 times 4, 32, and 6 times 8 is 48, plus 3, 51. So this right here is equal to 512. Okay? 8 to the third power, in other words, 8 cubed, equals 512. If I wanted to check that on the calculator, I could do that. Let's see. So we have 8 times 8 times 8 equals 512. Now you'll see on this calculator there's a little a squared symbol. So if we wanted to take a number, for example, let me make this bigger. If we wanted to take 8 squared, that would give us 64. Or for example, 7 squared is just 7 times 7 is 49. Or 36 squared is 36 times 36, which is 1,296. All right, that's a cool little button that you have on your calculator. Some buttons even also have the cubed button, right? So you can take, for example, 3 times 3 times 3. Instead of pressing that multiplication symbol, so many times, you could just press the cubed button and get 27. All right, so that's kind of a cool little feature with the calculator. You should know how to do these problems regularly before you can use the calculator, okay? The calculator is more just to rely on when you don't understand the problem, okay? We looked at this exercise last time. You can even play, if you really wanted to, this how to rush game on Mathplayground. Let's actually take a look at it. I think it's pretty cool. This will help you with exponents. I played it earlier today, and I think it's pretty neat. So let's just change our name to 5th grade, and let's get started. Play now. All right, so we're looking at exponents right now. Get ready. What times what equals 2? Well, 2 times itself equals 2. What times itself equals 12? Well, that's 12, right? Something times itself equals 27. Let's see, 3 times 3 is 9, times 3 is 27, so 3. What times itself equals 9? Well, 9, because it's a power of 1. Okay, what number times itself equals 16? 4. What number times itself equals 4? 2. Again, what number times itself equals 25? 5. Well, 4 to the power of 1 equals 4. 2 to the power of 2 equals 4. And 1 to the power of 2 is still 1. Okay, 3 times 3 is 9. And 6 times 6 is 36. 8 times 8 is 64. Look at that! Even with an explanation, we won the game. Okay, good. So hopefully you can play that game. In the notes section, you will see this link, so you can play that. And then there's another thing that's really important that we learn, which is called radicals. Now, radicals are a little bit more complex than exponents because you have to work with factors. Okay, it's really important that you know your multiplication facts when you're working with something called a radical. All right, let's actually make this a little bit bigger so we can see it. This radical, for example, would be 27 to like the third power. That index is that third. All right. Let's look at a couple of examples with this. For example, the radical of 3 times the radical of 15 is the same thing as the radical of 45, which you can break up into its factors, 9 times 5, okay? Which you can always simplify. Let's do a couple of problems together. For example, we have 48, radical 48, all right? Let me show you guys that one. This one's really interesting because you can take the base number, right? We have our base number is 48, and we can just break that into the separate, let me just eliminate this so we can see it more clearly. The separate factors, okay? So I'm going to break this up into the separate factors. We have 48, which we can break up into several different factors. For example, we can take 48, which equals 2 times 24. And 24 equals 2 times 12. And 12 equals 2 times 6. And 6 equals, change the color, 2 times 3. Okay, now what we're going to do is we're going to try to find the pairs. Well, if we find the pairs of numbers, I'm just going to circle them in a separate color. We have one pair of 2s, we have one pair of 3s, and then we have this lone number right here, that lone factor, 2. What we're going to do is we're going to multiply our pairs. So multiply our pairs, 2 times 3 equals 6, and I think I'm missing, oh, sorry, no, did that wrong. This is actually a 2. This is a 2. 2 times 3. So our pairs are actually 2 and 2. Sorry about that. Let's get rid of that. Okay, so we have 2 times 3. Our pair is actually right here. So we're going to multiply our pairs. So 2 times 2 equals 4, which is going to stay on the outside of our radical. And then our only number that's left over, our only factor that's left over is a 3. Okay, so what we're going to put is we're going to put that 3 inside of the radical, and then our final answer is that right there. So the radical of 48 would change to 4 on the outside and 3 on the inside. Okay, so those are different radicals that we could work with. Let's do maybe one more problem to understand the concept of radicals a little bit more. Let me erase this so we have some more space. Okay, again, radicals are pretty much just finding the factors of the number. Okay, so what we're going to do is find the factors of 72. Now, we're only trying to find those factors that are the smallest factors, right? The smallest whole numbers that go into the factor. So here we have 72. Well, just like it's an even number, we can divide that by 2. So 2 times 36 equals 72. 2 times 18 also equals 72. 2 times 9 equals 72. And 3 times 3 equals 72. Now I'm going to find my pairs again. So let's circle those pairs. We have a pair of 2s, we have a pair of 3's, and we have our lone 2. Okay, that lone 2 again is going to go on the inside of a radical, and we're going to multiply our pairs. So let's multiply those pairs. 2 times 3 equals 6. So our final answer for our radical 72 is 6 on the outside and 2 on the inside. Okay? When we say that, we can say that by saying that our index is 6 and our radicand is 2. The whole thing is called a radical. Okay, so for that last problem, we had 6 on the outside, that's our index, and 2 on the inside, that's our radicand. Our new radical is called 6, 2. Okay, the whole radical is 6, 2. Okay? All right, so those are just a couple of problems that you can practice for radicals. Again, in the prime book, we don't have radicals. If you wanted a little bit more practice, you could go to this website, kiwa.com, and play Who Wants to Be a Millionaire with the concept of radicals. Okay, so for example, if we just looked at this, the radical 18 would be 9, right? The radical 75 is 3, so we have 25 outside, and then we have the radical 3, right? So you could play that if you really wanted to. It's a pretty interesting game to understand radicals a little bit more. And next time, we're going to be getting into order of operation with more parentheses. So stay tuned for Friday's lesson, Friday the 20, I think it's the 29th? No, the 28th, I think. We will be getting into more, the 29th. Friday the 29th, we're going to be getting into more order of operations with parentheses. So we'll talk to you guys later.